right, you guys, so our last video for the week, we are looking at just-in-time 15.1, which is just a section with a bunch of trigonometric identities. All right, and these are all things that you're going to need to have memorized before a test. Okay, so our first trigonometric identity is kind of an extension of the Pythagorean theorem. It's just a Pythagorean identity for trig functions. Okay, so it is sine squared plus cosine squared is going to equal to 1. And almost all of our other trig identities that we'll use is come from this in some way, shape, or form. Okay, so our first one, we've got that if we take this and multiply the whole thing by 1 over cosine squared, we get that tan squared plus 1 is equal to secant squared. Okay, and if we take our Pythagorean identity and we multiply it by 1 over sine squared, we get 1 plus cotangent squared is equal to cosecant squared. Okay, we can also subtract, so we subtract over the cosine, so we get sine squared is equal to 1 minus cosine squared. If we take a square root, we get that sine is equal to plus or minus the square root of 1 minus cosine squared. Similarly, we can take and subtract the sine over, so we get that cosine squared is equal to 1 minus sine squared. And that should be a cosine is equal to plus or minus 1 minus sine squared. All right, and then we also get our angle sum formulas. So something to note with these, so we've got that sine of A plus or minus B is equal to sine A times cosine B plus or minus cosine of A sine of B. So whichever one you pick, so let's say I pick plus, then it's going to be a plus on the inside. If I had done subtraction, it would have been subtraction over there. Now that's different for the second one. So the second one, if I pick cosine of A plus B, it's going to be cosine of A times cosine of B minus sine of A times sine of B. Similarly, if I was going to subtract, I would have used the addition over here. Okay, so the second one, the signs are flipped, but you should just be able to read the sign straight across. All right, so if we want to do an example using these, so if we've got sine of pi over 3 plus pi over 6, okay, so that would be equal to sine pi over 3 times cosine of pi over 6 plus cosine of pi over 3 times sine of pi over 6. And we can take and substitute in. So we know from our unit circle, that's where we're getting all of these numbers. So from our unit circle, sine of pi over 3 is going to be square root of 3 over 2. Similarly, cosine of pi over 6 is going to be square root of 3 over 2, plus the cosine of pi over 3, which will be 1/2, and sine of pi over 6 will also be 1/2. Now, these happen to be the same purely because we picked these numbers, okay? That won't always be the case. But if we take and multiply, then we get 3/4 plus 1/4, which equals 1. Something to note, so if we would have taken and looked at this, so pi over 3 plus pi over 6 is the same as pi over 2, if I add those together, which we know should be 1, sine of pi over 2. We just kind of did it the long way so you could see the identity used. Now, sometimes they won't, so in this case, they gave it to you with the addition. Sometimes they won't. Sometimes they might say, hey, what's sine of this? And then you have to figure out what two things you need to add or subtract to be your two numbers. Okay. And sometimes they'll leave it with a variable in there. So if we've got sine of x plus pi over 2, okay, we do the same thing. We get sine of x, cosine of pi over 2, plus cosine of x times sine of pi over 2. Now, what's interesting about this one is that cosine of pi over 2 is 0, Sine of pi over 2 is 1. So what does that leave me with? Well, this whole thing is going to be 0. And then that just leaves me with a cosine of x. Okay? Which is kind of neat. All right. So then we also have our double angle formulas. So our double angle formulas are a special case of our sum angle formulas. They're angle sum formulas. So instead of having two different values that we're adding together, the double angle formulas are when we have the same value that we added twice. So in this case, we're looking at sine of 2 theta, which is sine of theta plus theta, so that value repeated. So we can use our angle sum formula, and we get down and it's sine of 2 theta is equal to 2 sine of theta cosine of theta. Okay, and so that's our double angle formula for sine. We also have our double angle formula for cosine, which would be cosine squared theta minus sine squared theta. All right, and you don't necessarily need to know how to derive these, although it's directly from the angle sum formula, but you do need to know the double angle formulas themselves. Okay, now something interesting is if we use the Pythagorean identity, okay, we can actually get two additional representations of cosine of 2 theta. So we can take this, so if we take cosine squared theta minus sine squared theta from up above, we can rewrite it using our Pythagorean identity, where we subtract that cosine over and rewrite sine in terms of cosine. And so that gives us another representation of cosine of 2 theta as 2 cosine squared theta minus 1. We also could do something similar. Instead of replacing the sine with cosine, we could replace the cosine with 1 minus sine squared. And that gives us that cosine of 2 theta is equal to 1 minus 2 sine squared of theta. Okay, so those are just other ways that we can rewrite it and look at it. All right, and so then from our double angle formula above, we can get our half angle formula. Okay, so double angle formulas, we can then get our half angle formula. So we get that sine of theta is equal to plus or minus the square root of 1 minus cosine of 2 theta divided by 2. And we get that cosine of theta is equal to plus or minus the square root of 1 plus cosine of 2 theta over sine. Now be careful, because cosine matches up, but it has a plus. Sine still has cosine, but it's got a minus. Okay, so be careful with that and don't just assume that, oh, it's sine, sine, cosine, cosine, because there is a difference there. All right, so we can use our half angle formula to find what cosine of 5 pi over 6 is, for an example. So if we apply our cosine of 5 pi over 6, we get negative square root of 1 plus cosine of 2 5 pi over 6 divided by 2. Now, we go with the negative because 5 pi over 6 is between pi over 2 and pi, which puts it in that second quadrant where we know that cosine is negative. Okay? Now, so we take that and then we plug in our 5 pi over 6 and for our theta and our half angle formula. And then we can do some simplification. Okay, so we carry the negative square root down, and so we get 1 plus, that ends up being 5 pi, cosine of 5 pi over 3, which is just 1/2 over 2. So negative square root of 3/2 over 2, which is just negative square root of 3/4, which is just negative root 3 over 2. Okay, so that's what cosine of 5 pi over 6 is equal to. All right, so this section I know was just a bunch of formulas and identities, but you need to make sure you have these memorized, and if you've got any questions about it, you can ask me in class or email me.